Good afternoon, everyone. So welcome to my YouTube channel, Maths Circle. Today we are going to see an important question. Sometimes, suppose you have a function f, whose absolute value function, it means mod f is Riemann integrable over closed interval ab. Does it is implies that f is Riemann integrable over ab? The answer is no. Okay, let's see it by example. Okay. For example, we are taking this function fx is equal to 1 if x is rational number in closed interval 0, 1, and you are taking -1 if x is irrational number in closed interval 0. Obviously, this function is bounded because its lower bound is -1 and upper bound is 1. So we can talk about Riemann integrability of this function. Okay. So now what is absolute function of it? Okay. So this function is bounded. What is absolute function? So you take absolute value of its functional values. So x is rational if in closed interval 0, 1. So 1 remain as it is because you take absolute value of positive number, it remains as it is. And -1 absolute value is if x is irrational. So -1 will become 1 because we are taking absolute value. So 1 if x is rational and 1 is irrational. So it is 1 overall closed interval 1, closed interval 0, 1. So this function is nothing but 1. So absolute value function is 1. It is constant function and constant functions are Riemann integrable over closed interval 0, 1. So this implies this absolute function is Riemann integrable on closed interval 0, 1. But f is not Riemann integrable over closed interval 0, 1. Why? You see the answer. Okay. You take any partition P of closed interval 0, 1. Okay. This partition, then what is UPF? UPF is summation I goes to n capital Mi delta xi. Capital Mi is supremum of f over subinterval xi minus 1 to xi. Because function is taking value, f is taking value -1 and 1. So it is supremum will be, Mi will be 1 because supremum is 1. And you take any subinterval, it will contain rational and irrational numbers as well. Okay. So 1 is here, Mi is 1 here. So I have put on the value of Mi is equal to 1 here. So it will be I goes to 1 to n summation delta xi. It is nothing but xn minus x naught. It is 1 minus 0. It is 1. UPF is 1 for any partition P of closed interval 0, 1. So upper integral will be infimum of UPF. Because UPF is 1 for any partition. So infimum will be 1. Okay. So it means upper integral is 1. Now, so upper integral, similarly, LPF is summation I goes to 1 to n small mi delta xi. Because infimum in subinterval of f is -1. I have put on the value -1 in place of small mi. To take -1 outside, summation I goes to 1 to n delta xi is 1 minus 0. It means it is 1. So -1 into 1, it is -1. So LPF is -1 for any partition. So lower integral will be supremum of LPF because LPF are -1 for any partition. So supremum will be, it means lower integral is going to be -1. Now see that upper integral is 1, lower integral is -1. So they are not equal. Upper integral is not equal to lower integral. It means f is not Riemann integrable over closed interval. So this is the example where absolute f, it means mod f function is Riemann integral, but f is need not be Riemann integral. It means f is not Riemann integrable here. So what is the general fact? If mod f is Riemann integrable, then f need not be Riemann integrable. Thank you very much for today's question. Thank you very much. Like, share, comment, and subscribe my YouTube channel. So we will see you next question. Thank you very much.